so let's have a quick think about the past work. Polkadot, past work. Well, I'm not going to go into too much detail here. I think the paper says it relatively in a relatively detailed fashion. I don't think I need to explain it too much. But Polkadot, firstly, had relatively high barriers to entry. You had to win a slot auction. Yeah, relatively few slots, and each slot can be used for one parachain. That's relaxing a little bit now with Agile Core Time and a few of the other bits of technologies. But broadly speaking, still fairly high, right? If you're going to use Polkadot, you're probably going to have to make your own chain. You have to run collators. It's not for the faint of heart. But more importantly, Polkadot enforces, or at least the traditional Polkadot model of parachains enforces persistent state partitioning. What do I mean by this? Well, I mean Polkadot has a number of state machines, parachains basically, that it oversees the progression of. And each of those state machines has some state. I mean, it's represented as a Merkle root, but it's still state. And that state is persistently split between each of the parachains. So if a smart contract exists on the Moonbeam parachain, it doesn't move, it cannot move to the Astar parachain. Now, if you do some very, very complicated trickery-pokery, you might be able to hack up a system such that you can make that work. But basically, it's impractical. Polkadot doesn't support that. And this can become a problem. And this puts Polkadot here, pushes it into this top left corner. Polkadot can grow very far, but it sacrifices a lot of its synchronicity when we view it as a single entity. Now, we can view it as a single entity because it does operate under a single consensus umbrella. That's what makes Polkadot different to systems like Cosmos, which don't. But Polkadot basically delivers parachains which sort of sit here on the curve and rather inter-parachain communication, which kind of sits here on the curve. Very, very potentially large amount of state that it can do, but very asynchronous, right? If you try and use XCM, you'll know this. When you try and send a message from one parachain to another, it will take some number of blocks to arrive, and the whole thing feels a lot less coherent. And here on the curve, which is basically the intra-parachain communication, where it's very much like Ethereum 1. It's a single chain, and it has a single sort of state, and you can do synchronous composability very easily. Now, the idea of JAM is to really say, well, maybe we can, I mean, in reality, we can probably move this down here and this over here. And in reality, JAM should be able to get more or less the same level of synchronicity as this X, more or less, and the same level of size as this X, more or less. Anyway. Okay, so that's the sort of critical view taken of Polkadot.